Before we talk about the social model though, I want to quickly switch gears and talk about forecast accuracy. Forecasting accuracy and control are vital to a business in a number of ways. For example, imagine you forecasted the following demand for a costume store like we did earlier. And like we said, because there is a higher demand in October, we would be making the following seasonal forecast. Now, what if the actual demand was more like this? In this scenario, because your forecast was overly optimistic, this would have led to an inventory that is over capacity or overstocked because you purchased more than you could actually sell. In such a scenario, your business would have not only incurred the costs of the goods you purchased but weren't able to sell, but other costs as well, and which we will go over in future chapters. In short, when you have accurate forecasts, you have optimized systems within your business. And when you have optimized systems, you increase profits while lowering costs. We'll now go through each of the following three methods in more details. For the purpose of this class, make sure you know the difference and then know how to do them. Needless to say, if I were you, I would definitely be putting these formulas onto my cheat sheet when I come in to take my exams. All right, let's do this. The first method we're going to look at is the mean absolute deviation method. Don't let this name intimidate you. Mean is another way of saying average, which is why we are taking the sum, here marked by the sigma symbol, of all the values, and then we are dividing it by n, which represents the number of values that we added together. Absolute means we are turning all the negatives into positive numbers, and that's represented right here. And deviation is another way of saying error because the error is the deviation from the forecast, which we learned earlier is the actual value minus the forecasted value. Okay, let's look at this excerpt from example 1 in your textbook on page 81. Whenever you see a question asking you to compute the mean absolute deviation, the first thing that I would do would be to write out the formula to help guide me along the way. So let's apply the formula to this question. Following the formula, the first thing we want to do is to calculate the error. Like we see here in the formula, you take the actual number and then you subtract the forecast. Next, directed by the summation symbol, we will add all the values of the error together to get -4. Then, the formula tells us we need to get the absolute value for each error. Once again, we sum up the values. And then finally, we see that we divide this value by n, which in this case, n equals 4. So 10 divided by 4 equals 2.5. This means that across all your data points, your forecast was off on average by around 2.5 units. Okay, now let's take a look at the mean squared error method. The mean squared error method is just like the mean absolute deviation method we just looked at, except for a couple of things. The first difference is we add an additional step. We are squaring the errors. And then secondly, we subtract 1 from n. Let's see this in action. Below we have the work we just completed in Excel form. And as I'm sure you guessed it, the next thing we're going to do is we're going to square the error. Now we get the sum, which equals 30. And now we want to divide this by n, which is 4, minus 1 equals 10. The MSE, or mean squared error, for this problem would be 10. So what is the difference between the two methods we just learned? Within the mean absolute deviation method, we weighed each error evenly. However, with the mean squared error method, we have placed more weight onto the larger errors, which could be more helpful when gauging a forecast accuracy. The mean absolute percent error method addresses a weakness in the previous two methods we just talked about. What do I mean by this? Using the same data source, we've got a value of 2.5 for the MAD and a value of 10 for the MSE. Looking at these numbers alone, there's very little insights to be gained. What does 2.5 mean? Was this error of 10 out of a forecast of 10 or out of a forecast of 1,000,000? In which case an error of 10 is pretty insignificant. In order to address these weaknesses, the mean absolute percent error converts these numbers into a relative percentage, which can be more insightful and helpful to understand. For example, if you have a mean absolute percent error of say 1.28%, this percent error value has the same meaning, regardless if you'd conducted a forecast of 10 or conducted a forecast of 1,000. Now let's apply the mean absolute percentage error to the problem we've been working on. Okay, so here we have the formula for the mean absolute percent error, which we'll be using to help guide us through the process. So first of all, we calculate the forecast error, which we have already done in the previous example. Next, we calculate the absolute value of the error, which we also have done previously. In the new step, we'll take the absolute value of the error, divide it by the actual value, and then multiply it by 100 to get a percentage. All right, let's do this. And once again, we get the sum, which gives us 4.698. So at this point, we've completed this part of our formula, and now we just need to divide it by n, which is 4. So 4.698 divided by 4 equals 1.175. We'll round that up to 8. And therefore, our mean absolute percent error equals 1.18%. And to reiterate what I said before, the benefit of using the mean absolute percent error is that 1.18%, this error means the same regardless of whether your sample set is a sample set of 10 or a sample set of 1,000,000. No matter what the size, this error percentage will mean the same thing. And with that, we've concluded the Chapter 3 forecasting video series.